My name is George Tan. I'm a PhD student at Georgia Institute of Technology. Have you ever looked at the stars and wondered about the mysteries of the night skies? Have you wondered if we are alone in this universe? Is there Earth-like planets in our solar system? Could they harbor life? These are a lot of questions that scientists ask and try to look for answers in the field of astrobiology. Astrobiology is a new and exciting field in the world of science. We are guided by three main fundamental questions. How does life begin and evolve? Is there life beyond Earth, and if so, how can we detect them? And what is the future of life on Earth and in the universe? Astrobiology is the study of origin, evolution, and distribution of life in the universe. The multidisciplinary field encompasses search for habitable planets in our solar system and habitable planets outside of our solar system. The search for the evidence of prebiotic chemistry and life on Mars and other bodies in our solar system. Laboratory and field research into the origin and early evolution of life on Earth, and studies of the potential for life to adapt to challenges on Earth and in space. We all seem to know if something is alive or not. But try coming up with a definition of life that everybody in the science community can agree on. It's really difficult. Astrobiology isn't so much the search for life as it is the search for answers. So how do we start looking for answers? A good start is to take a look at life on Earth as we know it. And we found that water is essential for life. From mammals to microbes, they all rely on water one way or other. The search for water on other planets isn't a concrete proof for life, but it surely increased the chances of finding one. Prokaryotes are abundant in extreme environments on Earth, such as radiation, toxic, or high temperatures. So scientists believe that bacterial or single-cell organisms are most likely to be found on other planets, due to their ability to survive extreme environments. But recent studies in Rio Tinto, which is known as Red River in southwestern Spain, proves that a lot of eukaryotes are surviving in these highly extreme environments. So today I will tell you about the two most interesting topics that I find in astrobiology. They are prebiotic chemistry of life and the development of instruments to look for life elsewhere. So what is prebiotic chemistry? Prebiotic chemistry is the study of chemistry before life. In 1953, Stanley Miller designed an experiment that simulated the conditions of early Earth. He heated up a water mixture of methane, ammonia, and hydrogen, and exposed the gaseous mixture to electrical spark. He then analyzed the solutions and found that there are amino acids in it. This is an exciting experiment because amino acids are the fundamental things of life, where he can generate from simple molecules. Since then, people get really interested in prebiotic chemistry. In the study of genetics, scientists are able to track back, based on our genes, the last universal common ancestors. So a lot of scientists are interested about the prebiotic chemistry of life, where they try to simulate or expose different chemical combinations on different early Earth conditions. Since no one knows about the early conditions of life on early Earth, all we can do is to predict and model early Earth conditions. This makes the study of prebiotic chemistry really challenging. One of the most exciting aspects of astrobiology is the search for life elsewhere. My research involved the development of analytical tools that can detect biosignatures on other planets. We detect chemicals or signs that show us there's existence of life. The search for life on other planets are really challenging because what we are looking for are just what we know on Earth. There might be other forms of life on other planets. Since we're detecting them using the way that we're looking for life as we know it on Earth, we might be detected in the wrong way and we couldn't detect anything. But what we know on Earth is the only guidance that we have to look for life elsewhere. So there are a lot of research going on trying to study terrestrial analogs, which are places on Earth that are similar to Mars or other planets, and try to get an insight and understanding of life that live in similar situations. Terrestrial analogs are the best sites that we could use to study life that has similar conditions of other planets. So people ask me, why am I interested in astrobiology? It is simple, because we all quest for answers and philosophies of life, and I think this is a meaningful research that I'm doing that could use my knowledge in analytical chemistry to solve one of mankind's issues. Even though this is a challenging field, I believe that with our hard work, we will one day find the answers. New innovations in technology and engineering drive new discoveries in science, which lead to the need of development of new instruments to verify the results. So it is your generation, you, who will be leading the future quest for life and potentially answer one of the most asked questions. Are we alone? Thank you.